Alright, this video is going to cover section 11.5 in the pre-calculus book. It's on change of base formula. Really what we're going to be doing is really talking a lot about how do we use our calculators to calculate log when we are not sure, when we don't have the ability to do the log base in our calculator. So we're going to evaluate expressions using logarithms and really going to get into how do we solve equations using logs. So when we have our log button on our calculator, and here, let me show you this calculator. Here's the log button right here. When we have that log button, and you probably have seen it for years, and maybe knew what it was for, maybe not. That's talking about finding the log base 10. Okay, so let's talk about what is the log base 10 of 1,000. So if I said log base 10 of 1,000, it's saying 10 to what exponent equals 1,000? Well, I happen to know that that exponent would have to be 3. All right, so now then if I ask you what's the log base 6, not as easy as the log base 10 of 1,000 because I can't just calculate it, but when I do have my calculator, I can say, okay, I have here the word log in there, log of 6, and I can say, please tell me what does that equal? 0.778. So I would put in here for my answer, it's 0.778. Same thing with that log of 81. Same process. I'm going to hit this log button, just hit the 81, and I don't have to have that second set of parentheses there. I can just do that, 1.908. So then I'd write here, well, that answer is 1.908. Most of the time when I have you go 3 decimal points beyond places beyond the decimal point to the nearest hundredth. Okay, so now just like we can multiply or add to both sides of an equation by a value, you can take the log of both sides of an equation. And when you do, you can take the log base 10 because you know you can find that on your calculator. So for this problem right here, I would take the log of both sides. So the log of 6 to the 3x equals the log base 10 of 81. Because what we did before is when we had the log of both sides, we could just ignore it. We got rid of it. Now we can kind of add it back in. Well, now I can use the property that says when I have an exponent, it can become a coefficient. So now this exponent is going to be my coefficient. 3x times log of base 10 of 6, and I'm just going to say log of 6 from now on, equals log of 81. Well, what I can do to both sides is I can divide both sides by this log of 6. So now my problem becomes 3x equals whatever we have when we have the log of 81 divided by the log of 6. Well, that's where I'm going to get my calculator. And I'm going to say, oh, by the way, what is the log of 81? And here I do need the parenthesis to say, okay, I just want the log of 81. And I'm going to divide it by the log of 6. So it is important to have the parentheses in the right spot. I got an answer, 2.452. I'd round that 2 up to a 3, so it's 2.453. So I got here 2.453. And then I want to divide both sides by 3 here. Excuse me, this was 3x. Sorry, I had a 3x here. And so x would equal, I have to go back to my calculator, divide that answer by 3 to get an answer of 0.81, and I'm going to call it 8.818. So my x equals 0.818. That's what my answer is for this value. So there are times I couldn't have just done this with like kind of using logic and having the common bases because there is no common base, but this does work to have the logs. And what happens is you kind of quickly realize that there's kind of a pattern to it, or you can even call it a formula, that the exponent, in this case my exponent is x minus 2, will always equal the log of the number that it was on the other side of the equal sign to the log of the base divided by the log of the base. And so that's going to kind of be our change of base formula. It's always going to be the log of whatever it was set equal to divided by the log of the base. So here I would just have x minus 2 equals, and I have to go log of 4 divided by log of 6, log of 4 parentheses divided by log of 6. And I got for an answer 0.77. And if you notice, that was like 0.77 something. And we would have to add 2 to it to see what would x be, because it was x minus 2. So when I add 2 to it, I get 2.774. So I got for an answer that my x must equal 2.774. All right, and that's my answer there. So our change of base formula says that if a, b, and n are positive numbers and neither a nor b is 1, okay, then the following will be true. All right, so this also works, and it's basically saying it also works if we have an exponent. Okay, so I think it'd be best if I just show you with the log base 3 of 9. Well, okay, so I have log base 3 of 9, and I'm kind of prove why we have this change of base formula. I think I might even move this up here so I have some space. And then if I said it was equal to x, what I would be saying to myself is that 3 to the x equals 9. Now I know we know how to solve this, but let's pretend we don't. I could take the log of both sides of my equation, bring the x out in front, and so I'd have x log of 3 equals the log of 9. So then if I divide both sides by log of x, x would equal log of 9 divided by log of 3. Okay? Get a handy dandy calculator that's a scientific calculator. Log of, was it log of 3 or log of 9? I gotta go back here. Log of 9 divided by log of 3. Thank you. All right, so log of 9 divided by log of 3, and my answer is 2. So my answer here, oops, there we go. My answer here was that x equals 2. And I always just took the log of what it was set equal, or the whole number, the value, divided by the log of the base. Okay? So for this problem here, my value would be the log of 7 divided by the log of 4. You're always dividing by the log of the base. So I get here, get to my calculator, log of 7 divided by log of 4. Answer there, 1.404. Okay? So I had an answer of 1.404. Okay? I'm going to go ahead and work out the other two. Go ahead, pause it. You can work it out in your calculator and see if you're getting the same answers as I. And there magically are the next two answers. So you can kind of calculate that on your own personal calculator and make sure you're getting the same answers. So now, how does this work when we have equations? And I've kind of already shown you this, that the exponent always equals the log of the value it equals divided by the log of the base. So in this case, I just need to go on the calculator and take the log of 41 and divide it by the log of 3 for that particular problem. I got an answer of 3.380. So my answer here was 3.380. All right, and I'm going to have you go to the nearest hundredth. Here, the only difference is we're going to take x minus 5, and it's going to equal the log of 9.32 divided by the log of 2.2. That's the only difference here, and that answer is 2.831. The next problem is kind of interesting. We're actually used to seeing it like this. Log of 16, log base 10 of 16 to the x equals 0.25. What I would do here first, it's already kind of put into the form. I would first take my exponent and make it the coefficient. All right, so I would first think of it as x times log of 16, and then that equals 0.25. All right, and so really we just have to go and divide both sides by log of 16. That's an actual value here, this log of 16. This reduces down. And so our x equals 0.25 divided by log of, was it 16? Gosh, I hope I'm right, 16. All right, and so when I go back and I look at that, log of 6, I gotta look at what it is again, 0.208 would be my answer. 0.208 for my answer there. So I did have to do a little bit of work to get that worked out. Now, interesting problem here, this one, and you're going to have problems like this on your assignment, where you have two variables. And what you do is you do take the log of both sides. So you say the log of 5 to the x. I think it just kind of works better if you think of it this way. Equals log of 4 to the x plus 3. And then for both of them, you're going to move your exponents and make them the coefficients. So x times log of 5 equals x plus 3 here times log of 4. And then what I would do, it kind of depends on where you are, but I'd probably take, I got to decide here. I think what I'm going to do is I'm going to divide both sides by log of 4, just because it'd be easier. So I'm going to divide both sides by log of 4. I'm going to need a little bit extra space, and that's okay. I'll make it here for myself. All right, so now what I'm doing here when I divided both sides by log of 4 is I'm going to figure out what is the log of 5 divided by the log of 4. So the log of 5 divided by the log of 4, and I'm going to calculate that value, 1.161. So again, we're going to round to the nearest hundredth. So this is x times 1.161. So 1.161 equals, and this went away, x plus 3. Well, let's take away 1 from both sides, 1x from both sides. So if I did this and I said I'm going to take away a 1x, all right, I have just the 0.161. So 0.161x would equal 3. Now my problem becomes, what is 3 divided by 0.161? And I got 18.634 actually. So in the end, my x equaled 18. I gotta think what it was again. 634. There we go. So that was my answer. It took a little bit of time to get to that answer, but that's how we work out the answer. Slightly different here, only slightly. So again, you have two logs. You're going to just take the log of both sides. Log of 5 to the x equal log of 4 to the x plus 2. Make your exponents the coefficients. So x times this log of 5 now equals x plus 2 times this log of 4. Well, again, I'm going to take log of 5 divided by log of 4. I think that's just the quickest way to get rid of this. So I'm going to divide both sides by log of 4 here. And actually, I had that same value up here. So I know that what we have is 1.161x. Now it equals x plus 2. When I subtract x from both sides, 1x, I get 0.161 equals 2. And this is x, sorry. So my problem just becomes what's 2 divided by 0.161. 2 divided by 0.161. I get for a final answer of 12.422. All right, so my x in the end was 12.422. The hardest part is going to be just using your calculators and kind of calculating with your calculators. So I want you to complete the worksheet, the 11.5 worksheet. Let's talk about this anti-log. On the calculators, this anti-log that you're going to see is just the inverse of the log. So we're trying to find the anti-log here of negative 0.06, and really that's all I need to know. So all I do here is I'm going to go second log, and you're going to see 10 there, and that's okay, and it was negative 0.0600. I don't need those other two zeros, but it was on there, and I'm just going to get the answer, 0.871. So my answer here is just 0.871. We're not going to use the terminologies anti-log very often, but in case you ever see it on an ACT test, in a science class, I wanted you to have some experience with it. So really that's all I need you to know when it says anti-log. What anti-log is just another way to say log inverse. They don't usually say log inverse because that exponent of a -1 can kind of get lost within the log notation. So anti-log is just the second or the inverse of the log. So it's not so bad. So for these problems, it's really going to be about using your calculator. Log of 8 divided by log of 2. I'm going to let you calculate that on your calculator. These problems, it's just going to be about reminding yourself that the exponent equals the log of the value on the outside of the equal sign divided by the log of the base. I'm going to let you work that out. You have to take log of 200 divided by log of 6.5 and then subtract 3 from both sides. Good luck!